Hey, Haley, I know we're just having stories. Haley, this is section 6-4. We are filling in this top little box right here because we're talking about rectangles today. So, oh, I'm delayed. Am I delayed? Ooh. Okay, so we just fill in the parallelogram box. I'm going to zoom out a little bit. So we have a rectangle. And one thing that I will say here is on this rectangle box, you see where it says star parallelogram, right? What that means is that all of these things apply. And in addition to that, we have two more special things that a rectangle has that a regular old parallelogram does not, okay? So that's kind of how that works. All of these things apply, but in addition to that, two more, okay? So he has a parallelogram, great. Now there's one more thing about the angles that's really special just for rectangles, is that they're all 90 degrees. So I'm going to put that down, all 90-degree angles. Not hard, right? Like we knew that. So I'm going to put the boxes in the corner so that we know that he is... has all 90-degree angles, like that, okay? And then one more special thing about the diagonals. So let's go back over to parallelogram and let's talk about his diagonals, okay? One thing that we said about parallelogram is that the diagonals are not the same length. Like this one is longer than this one, right? Like the ones that are further apart has a longer diagonal than the other ones. But we do know that for a parallelogram, it splits in half, right? So like this chunk will be the same as this one, right? And this chunk will be the same as this one, okay? But for a rectangle, when we draw his diagonals, like from here to here and here to here, whoop, let me go back. What do we know about his diagonals? They are going to be the same. Not only do they split each other in half, they are going to be the same length because they're like the same opposite corners. So the diagonals are both congruent, right? Make sense? Okay, so we've got that important information. Now, let's talk more about a rectangle and like these angles up here, like this angle versus this one. So I know that that's a 90-degree angle, and if I split that in half, it's 45. Is this going to be 45 and this going to be 45? No, it does not split it in half, so don't think that. Those angles are not split exactly in two equal pieces, so not true. The diagonals still bisect each other, so this length is still going to be the same as this one. This length is still going to be the same as this one, etc., right? Okay, so still have the same qualities as a parallelogram, but just those two extra things. Okay, good? That's it. All right, so let's go to the notes, and we'll talk through some of those. Let me go to...
Which one's the easiest one to do?
What? Probably rectangle. So yeah, today's lesson is going to be really easy. Rhombus and like squares are pretty easy also, but they lump them in together with rhombus. So we'll do rhombus and square tomorrow, 6-5. So we're doing two shapes tomorrow rather than just one, but rhombus and square go together really, really well. So I would probably say that square is the easiest one, but since it's lumped in with rhombus, that probably makes that section a little bit harder. But anyway, whatever, they're all pretty easy. Rectangles, some of the things that we've put down already, all four angles are right angles. You can see that from the boxes here. The second bullet point says opposite sides are parallel and congruent. They have one of those markings on here, but they don't have the other one. What marking do they have? They have congruent, but they don't have parallel. So if you want to go ahead and put parallel on there, parallel, parallel, and parallel, parallel, okay? That tells me that they are parallel also. Parallel and congruent don't mean the same thing, etc., right? Okay, number 3, opposite angles are congruent. So these guys are the same measure because they're all 90s, right? These guys are the same measure. So that's kind of that third bullet point. I'm going to get rid of my triangle, my arrows here. Then number 4 says consecutive angles are supplementary. Okay, let's talk about what that means. What does that mean? One's next to each other. So give me two that are next to each other. A and D, sure. Okay, I heard a lot of combinations, but A and D. Supplementary means they add up to be 180. So since they're both 90s, they add up to be 180. These two are also consecutive. These two are also consecutive. These two are also consecutive. So regardless of which consecutive pair you look at, they're all equal to 180. Okay, I'm going to get rid of those markings. Okay. And last bullet point says the diagonals bisect each other, which we already knew from it being a parallelogram. So we've got this corner to that one, this corner to that one, and we've got this length is the same as this one, and this length is the same as this length, right? We already knew that from it being a parallelogram. Okay, so all of those things are still going to apply for rectangles. Good? We're going to have us answer some questions, right? And these are pretty straightforward, easy questions. A rectangular park has 2 walking paths as shown. Okay, what are the walking paths? P, R, and S, Q, and these are the diagonals. Yeah, so we got a diagonal here. I'm going to do that in a different color. This guy right here. And this guy. Those are my diagonals. Okay, it says if PS. Now, PS is a side from here to here. It's not one of the diagonals. This is 180 meters. Okay, and it says PR is 200 meters. Okay, PR is this length from here to here. That's 200. They want to know what the length of QT is. And T is the middle dot. I kind of got rid of him. T is this middle. QT is this length here. What is that going to be? Yeah, Jake said 100 because it is half of the whole length, and since the whole lengths are the same for each one, QT is going to be 100 meters. Perfect. Yeah, not too bad. Okay, example 2. Be careful when you're reading through the instructions up here so that you know what you're marking. Like I have a lot of people that look at 2x plus 4 and they write it down as one of the lengths of the side. But we're talking about angle KJL. Okay, look at angle KJL. He is located just this guy right here. Just this angle right here is KJL. So that's 2x plus 4. Okay, not the whole thing, not the 90-degree angle. 2x plus 4 is that guy. Okay, then the other one says the measure of angle JLK. Did you find JLK? This bottom corner right here is 7x plus 5. Just that little bit, not the whole 90-degree angle, just from here to here. Okay? All right, they want us to solve for x. Are those two the same? Like, I'm always tempted to just set them equal to each other and say, call it a day, right? Are they the same? Okay, so I take a look at like just look at this as a triangle right here, right? Okay, just look at that triangle, ignore everything else. This is a 90-degree angle up here, okay? So if all 3 of them add up to be 180, then this one and this one together have to add up to be the other 90, right? You see that? Okay, so they're not equal to each other, but we know that they add up to be 90. So 2x plus 4 plus this guy, 7x plus 5, equals 90 degrees, right? And then we just solve. 9x plus 9 equals 90. There's lots of 9's in this problem. Minus 9 over. 9x equals 81. Okay, divide by 9. There's lots of 9's going on here. X equals 9. Okay, do we have to plug back in? Find x. Nope, find x. That's it. That's it. Right. Yes, yes. So, Libby said, okay, can we do this? And what you can say is like this angle right here will be the same as this one because they're alternate interior, right? Like,
Yeah, that's
right?
the same.
So 7x plus 5 works that way also. And you can see that those two have to add up to be 90 that way also. Yep, yep. You can totally do that as well. That's a very, very good thought. Or you can move this 2x plus 4 down here. 2x plus 4 because they're alternate interior as well. And then you can see that those two have to add up to be 90. Totally true. Very good point. I like that a lot. This bottom one just says that the diagonals are going to be equal in a rectangle, which we already went over that in our little box thing. So let's go to the back side and let's answer some more questions. Here we have a community recreation center has created an outdoor dodgeball playing field. And every time I come across this example, I always have to chuckle because I'm like, I really hope that they have a fence around this outdoor playing area. Otherwise, they're not going to get much dodgeball played, right? Like they're just going to end up running after the ball outside of the court the whole time, right? To be sure that it meets the ideal playing field requirements, they measure the sides of the field and its diagonals. Okay, so let's label some things. It says that AB is 60. AB is this top side here, that's 60 feet. Okay, BC, this length here is 30 feet. Okay, CD is this guy here, which is another 60 feet. And AD is 30 feet. Okay, now I'm going to stop there and I'm not going to read the diagonal part. But if we have just this information, just those sides, is that enough for me to say that that is a rectangle?
It could be, because
Yeah, so this tells me, okay, I'm going to say, do this. I'm going to say opposite sides are congruent. That makes it a parallelogram, right? Okay, but this is like, what? Yeah, go ahead and write this part down. Okay, opposite sides congruent means that it's a parallelogram. Okay, my husband does this all the time when he's framing a house. Have you ever seen a house being framed before? Like what they'll do, like where they're building the sides of a house. Okay, so he will literally have this part. This is like a wall, and he's building it on the ground, right, before they like raise it up to the sides. Okay, and then you have these guys in the middle, which are called studs, right? And that's where like your insulation goes in between those guys. Okay, but what happens is every once in a while, when he is doing that and laying it out, it gets a slight tilt to it, like not even this much of a tilt, like you can't even tell that it has a tilt, right? Ooh, that was a really bad line. Okay, it gets a tilt to it where it's not perfectly at a 90-degree angle. He's measured it so that like, this is 30, this is 60, this is 60, this is 30, and he's put all the studs in here that are 30s also, but it has a slight tilt to it, right? Okay, and so what he does instead is after he gets that, all those measurements are the same, the very next thing that he does is he measures from this corner to this corner, which is a diagonal. And then he uses his tape measure and does the same thing for this corner to this corner, and he sees if they match each other, right? And if they don't match, like one is just slightly longer than the other one, he'll like tap one of the corners to make it go in, you know, like just ever so slightly, and then he'll measure again to make sure that they are the same. And before he raises that wall up, he like screws the board from here to here, right, to make sure it stays in that same spot, raises it up, raises all four sides of the wall up, screws all four sides of the wall together, and then he takes that diagonal board off, right, to make sure that it doesn't tilt ever so slightly, because if it tilts ever so slightly, and that's the foundation of your house, your foundation's going to be off, and then you're like going to be like the rafters are not going to go together correctly, and then you're, you know, everything's going to be off ever so slightly, and then you're going to be really screwed at the end. So just because the sides match up doesn't mean it won't have just a slight tilt to it. So what we do, rather than just measuring the opposite sides, is we also do the diagonals. So they say the diagonal from here to here is 67 feet, and the diagonal from here to here is also 67 feet. So diagonals congruent means that it has to be a rectangle then, right? Okay, so explain how the recreation center can be sure that the playing field is rectangular. We know if the opposite sides are the same, it's a parallelogram, but then from there, if we measure the diagonals, it has to be a rectangle, right? That's kind of how that works. Okay, happy with that? Not too bad? Okay, is this the last example? Hey, you betcha. All right, okay. Yeah, we are going speedy. Example 4, let's do some plotting points here. So -5 is at 3, and that is P. 1, -1. It kind of does. There is that. He does look like a rectangle. Okay, and they're asking us to determine whether it's a rectangle using the distance formula. Oh man. All right, and then somebody's peeking in here. And then, in addition to the distance formula, what we're going to do is one more thing, because I know they're going to ask you on your homework assignment. We're going to talk through the slope formula, because the slope formula is actually a little bit easier. Luke was actually kind of going through this morning in his head. So slope formula is actually a little bit easier than distance formula. I'll show you why here in a second. Okay, so distance formula. We always do shortcuts on distance formula. The first thing that we want to do is measure all of the sides for the distances.
All of them?
Yeah, there's 4 sides. I know. So name me one side. Let's name all of them. PQ is a side. Okay. Equals. QR is another side. Keep going around. RS and SP.
SP!
What does SP mean?
Speed Parker.
What is that?
It's a cross country name.
Oh, okay. All right. Inside joke. I have no idea what that is. All right. So we're doing all these distances, and we do the shortcut formula for distance because we just we do some of the stuff in our head, right? Okay. So get that guy written out, and then we'll go from there. PQ, QR, RS, SP, or PS. Whatever. Okay, all right, so let's start with PQ. Looking at this diagram, we look at the x's and we say how far apart are the x's. So from -5 to +1, that is 6 units. How far apart are the y's? From 3 to -1? 4. So we have 6 squared plus 4 squared. Okay, 6 squared is 36, 4 squared is 16. 36 plus 16 is 52. There we go. She's on a roll today. 52, the square root of 52. You can figure out what that is as a decimal, but we're just going to leave it. Okay, now we're going to do QR, which is the next one. Q to R. We've got from -1 to +1. That's 2 squared plus from -4 to -1 is 3. Okay, so 2 squared is 4, 3 squared is 9, which is the square root of 13. Beautiful. Okay, now we're going RS. So from -7 to -1 is 6, she says, plus 0 to 4 is 0 to -4 is 4. 6 squared, 4 squared. Hey, we did that already. 52 again. Okay? And, oh, by the way, if that was not the square root of 52, we could stop because it's going to be a no, right? Yeah, but they're mean, so we have to. Yeah, it might have to be a rectangle. All right, so now we go from P to S. Whoop. P to S, so -7 and -5. Is 2 plus 3. You said 2, 3 again, right? And that's the square root of 13. Okay, now, is it a rectangle?
No. Well, maybe. It's a parallelogram.
Ooh, this only tells us, unfortunately, this is a parallelogram. So, yes, parallelogram. But we don't necessarily know that it is a rectangle. What can we do now to find that it's a rectangle? Oh, no, we got to do 2 more. The diagonals. Name one diagonal. PR, and the other one is SQ. Okay. All right, so we're going to do diagonal, and then we're going to see if these two match. All right, so from P to R, from -5 to -1 is 4, and from 3 to -4, 7. 4 squared is 16, 7 squared is 49, 16 and 49 make 65, I think. Okay, SQ, from -7 to 1. 8, uh-oh, this is looking like it's maybe not. 0 to 1 is 1. 8 squared is 64, 1 squared is, they just made 65 a different way. Ha, look at them go, they're tricksters. I know, right? Right? But there's different ways to make the same number. So now we know for sure that yes, it is a parallelogram, right? Or not parallelogram. Thank you. Rectangle. Yes, it's a rectangle. So you have to do 6 of them. What a pain in the butt. All right. Rather than, okay, let's do some slopey things here. Ready? Let's do some slopey things. And I'm just going to do the slopey things on the picture thing here.
Do you have to do more slopey things?
No, just wait. You only have to do 4 slopey things, okay? So, slopey thing is a little bit easier. All right, let's do the slopey things from this guy to this guy. So just count up. Since we have it drawn, let's count up and count over. So from this point to this point, how many is going up and over?
How would you do that if it wasn't drawn?
You do, okay, so if he's not drawn, you do y2 minus y1 over x2 minus x1.
Okay.
Right? Yeah, okay. So, since we have them drawn, we'll just count up and over. So, up and over, this guy has a slope of up 3 and over 2, yeah? Okay, let's check his opposite. Is he also up 3 and over 2? Yes. Okay, so those two are parallel, yeah? Okay, now let's see if the other two are parallel. So, from this top corner to this corner, he is going down 4 and over 6.
Yeah.
So, -4 over 6, which reduces to -2 over 3. So we've got these right here. Let's see if this one's also -2 over 3. Is he going down 4 over 6? Down 4 over 6, so also negative 2 over 3. Okay, now here's the kicker. Ready? Is he a parallelogram?
Yeah.
Yes, because his opposite ones are congruent. Or opposite ones are parallel, right? Opposite ones are parallel. But also,
They're reciprocal.
they're negative reciprocals, which means what?
Perpendicular.
These are perpendicular, right? Right?
Whoa.
So because the slopes are perpendicular slopes, we know that each one is a 90-degree angle, which means that it has to be a rectangle, right? So by proving that they're negative reciprocals, so check. So on slope formula, opposite slopes must equal, and I'm going to say consecutive. What does consecutive mean again? Like the ones right next to each other. Consecutive slopes must be negative reciprocals, because that shows me that they are perpendicular. Negative recips, which means perpendicular. Yeah, makes sense? So that one is a little less work because you only have to do 4 things rather than the 6 above, right? Does that make sense? Okay. So on your homework assignment, I'm only going to make you do one of each of those on the homework assignment, okay? So 6-4 on skills practice. Do you guys have this paper yet? Yeah, 6 skills. So you can cross off the proof and you can cross off 10 and 12. So you only have to do 11, which is a distance formula 1. Ugh.
On skills practice?
On skills practice. And so 1 through 8 and then 11 is the only ones you have to do. You can cross off the rest of them. Okay? 1 through 8 and 11. So you have this whole room over here at the bottom to do that number 11, right? If you need to, okay? And then on the back side, just cross off 14, 15. 16 is easy.
Okay.
It's really easy, actually. 16 is really easy, actually. So you have this whole room over here to do your slopes, okay?
Why would we do it anyways?
Yeah, we're
What?
just gonna come in tomorrow and be like,
Just read it. It's really easy. It's really easy. It's just basically like 16 is a yes or no question, by the way. So there's that. Okay? All right.
Yes, is it right?
So do those guys. What? I don't know. Read the question.
Yes. It is yes. Jalen, it's yes.
Can I go grab a sweat? Can I go pee? What do you want, Angel?
I don't know.
Okay. Everybody say bye, Haley.
Go pee.